Hello, welcome to today's class. Today we have this polynomial equation. It's a special one. The question is k to the power of 3 minus k equal to 9 to the power of 3 minus 9. Now, if you look at this question carefully, you discover that 9 is one of the roots here. Because if we put in 9 here raised to the power of 3, then we put in 9 here is equivalent to what we have on the left-hand side. Sorry, the right-hand side here, right? But here we have 3 as the highest power. So what are the other two roots to this math problem? That is the essence of this video. All right, but before we continue, if you're new here, this is Online Maths TV. If you've not subscribed, subscribe. And when you subscribe, turn on the notification bell so that you get notified whenever we drop an amazing video. So let's take our solution from here. So here we have solution. All right. Now, the first thing we're going to do here is to move the quantities on the right-hand side to the left-hand side. And so this is going to give us our k to the power of 3, then minus k, then minus our 9 to the power of 3, then plus our 9. Everything equal to 0. Here we are having k to the power of 3, and here we are having 9 to the power of 3. So let's bring these together. This to the power of 1 and this to the power of 1. So this is going to give us our k to the power of 3, then minus 9 to the power of 3, then minus our k, then plus our 9 equal to 0. So with this, we can put this in bracket and also put this in bracket. So if we rearrange this, it's going to give us our k to the power of 3 minus 9 to the power of 3, or in bracket, then minus. When we put this in bracket, this sign will change to minus. So we have k minus 9 close bracket equal to 0. What we do next here is this. We have what is called difference of 2 cubes. So we want to apply difference of 2 cubes to this part of the expression. We know that if you have your e, okay, to the power of 3, then minus b to the power of 3, this is equal to bracket a minus b close bracket your a to the power of 2, then plus your a b, then plus your b to the power of 2. This is your difference of 2 cubes. So we have this expression in this equation also. So we want to rewrite this in this format. So rewriting this, that is going to give us our k, right, minus our 9 close bracket, then bracket open, k to the power of 2, then plus our k, 9k, let's put it straight. So 9k, then plus our 9 to the power of 2, close bracket. We bring out this term here. So minus bracket k minus 9, close bracket. This is equal to 0. Okay, so we can open up this. In other words, our 9 to the power of 2 is 81. So this is going to give us k, then minus 9, close bracket, bracket k to the power of 2, plus 9k, then plus our 81, close bracket, minus bracket k, minus 9, close bracket equal to 0. Now, if you look carefully, you discover we have k minus 9 and we have k minus 9 here. So we can factor that out. So if we go ahead to factor that out, it's going to give us our k minus 9 or in bracket, then square bracket open bracket. If we use this to divide this, here we are left with our k to the power of 2, then plus 9k, then plus our 81, close bracket, then minus. If we use this to divide this, we are left with just 1. Then let's close our square bracket, everything equal to 0. So what we do next here is this. Let's go ahead and input the bracket we have inside this expression here. So this is going to give us our k minus our 9, close bracket, the bracket, our k to the power of 2, the plus 9k. Then if we open this, we're going to have 81 minus 1, close bracket, equal to 0. So again, if we expand this, then this is going to give us bracket k minus 9, close bracket, bracket k to the power of 2, then plus our 9k, then plus our 80, close bracket, this is 80, this is equal to 0. We apply what is called the zero property, okay, whereby we equate this to 0, we equate this to 0. So we have two cases scenario here. So let's take our case 1. So case 1, we're going to have our k minus 9 equal to 0. So therefore, we cannot have our k1. Our k1 is equal to our positive 9. So we have here case 2. We have our k to the power of 2, then plus 9k, then plus our 80 equal to 0. Okay, yeah, this is a quadratic equation. So we want to solve this using the quadratic formula. So we know the quadratic formula says yeah, that our k is equal to our minus b plus minus the square root of our b to the power of 2 minus 4ac all over 2a. Okay, here we have our a. So our a is the coefficient of the k square, which is equal to 1, and our b is the coefficient of k, which is 9 here. We have 9 here, and c is the constant term, which is 80. So we have our 80 here. So this gives us our k will now be equal to minus 9 log minus the square root of our positive 9 to the power of 2 minus 4, then times our 1 times our 80, close bracket, then everything all over 2 times 1. There. Let's continue. This is equal to minus 9 plus minus the square root. This will give us our 9 to the power of 2 will give us our 81. Then minus 4 times 1 is 4. Then 4 times 80, that will give us 320. So we have here 320. Okay, so all over our 2, because 2 times 1 will give us our 2. So if we subtract 81 from 320, that will give us 239, right? So this is equal to our minus 9 plus minus the square root of our minus 239. Okay, everything all over 2. All right, we bring in or we rewrite this expression first. We know that the square root of iota square root of our minus 1 is equals to iota. And we can split this expression into minus 1 times 239. So if we go ahead to do that, then this is going to give us minus 9 plus minus the iota into the square root of our 239. Everything all over R2. Now, if you check out carefully, our 239 is a prime number. So we cannot factorize this beyond this level. And so we have two solutions to this expression we have in here. So what are the solutions here now? So we have our K1 and K2 to this here. So we have our K2 is equal to minus 9, the plus iota into square root of 239 all over our 2. And we have our K3 is equal to our minus 9 minus iota root 239 all over our 2 here. So you see that we have 2 imaginary roots to this challenge, and we have just 1 real solution, which is the 9 we solved for here. So this brings us to the end of this math class. Learn something from this video. Do not forget to give the video a thumbs up, and if you're new here, do not forget to subscribe. Here we release videos all the time for our learning. Thank you for being there. Until we meet you in our next class, keep winning.